So more complex related rates. 2.6. More complex related rates. So the process we're going to go through is exactly the same. But the equations we use, or the variables, there's maybe more variables or more things, or we have to come up with an equation. It's not clear enough what the equation is. We have to come up with an equation. A little bit more, some more complex situations we're gonna come up with. So the process is the same. Process is the same. We are going to find an equation, find a formula. We're going to take the derivative, take d dt. We're going to plug in the known values, known values, and we are going to find the missing value. Okay. Same steps that we did before. So, what's an example of something that's a little more complicated? Let's say we have a cone-shaped tank of water. Is being filled at a rate of, let's say, 3 cubic feet per minute. A cone-shaped tank of water is being filled at a rate of 3 cubic feet per minute. Find the rate of increase of the height of the water if, or I should say at, or when it is 1/2 full, if the height is 10 feet, radius is 5 feet, and dr dt let's see, is 1 foot per minute. Okay. So we got some information about a cone-shaped tank of water. We know its rate of being filled. This rate of being filled, what variable does this rate represent? Well, we're talking about rate of increase of a tank of water. What is that? What does this rate correspond to in terms of the tank? What feature of the tank is this 3 feet per minute? It's R is 5. That's 5 feet. 5 feet. 5 feet. What feature of the tank, though, is this filling amount being, like, what is this telling us? What part of the formula, what part of the what feature of the tank? I don't know how to say. I don't know how to describe. I don't know what a good way to say this is. What part of an equation, or what feature about the tank is this 3 cubic feet per minute representing? Is it radius? Is this an increase in the height? What is this an increase of? Think you have this 3D cone. What variable does this 3 cubic feet per minute represent? Anybody have an idea? 3 cubic feet per minute. The hint is there, cubic feet. What type of information is measured in cubic feet? Exactly, Perry, so thank you. The volume. This is dV dt. Rate of increase, right? You're pouring water into the tank at 3 cubic feet per minute. That's a change in volume of what's inside the tank. Exactly. So, let's draw a picture of this tank. Here, we've got our conical tank. We've got some water flowing in at 3 cubic feet per minute, dV dt. And we've got some other information. We've got the height of the tank, where we are, the point we're concerned about is 10 feet. Oopsies. 10 feet. This is h, the height of the tank. The radius at the top here, at that point in time, that's 5 feet. And we know the change in radius, dr dt, over time, is 1 foot per minute. And all of this, of course, has to do with, like, the shape of the tank, the width, the height, all this stuff. But they've given us this information, and the thing we want to find out, the information we want to know, is we want to know, find the rate of increase of the height of the tank. So we want to know dH dt. We want to know what is the change of height. How quickly is the height dH dt changing? If we were sitting in the tank, we want to know how much time before the tank covers our head, right? So that's our question here. It's a very James Bond question. How much time do we have before we drown in this tank of water? No, Mr. Bond, I expect you to die. So let's find out. First of all, what equation, right? First step we do here. First step, find a formula. What formula? Da-da. Oh, what's the da-da, da-da, ba-da-da. Yeah, there you go. Anyway, what formula? Step one. What equation do we use in this situation? What equation do we use for this context? We have a tank filled with water. What does it say in red next to question mark? This says dH dt. Let me do a little better here. dH dt. Oh, what happened? dH dt. It's what we want to know. But the height's going up, so we want to know the height increase. So we got all this information, right? The changing of the radius is growing because the tank is filling, right? The radius is growing. Radius is increasing. Height's increasing by some amount per minute. We want to find out what is the change of height. So, what formula do we use? Well, we're talking about volume of a tank, so probably going to use the formula for the volume of a tank. The volume of a tank, formula for the volume of a cylinder of a cone here. Volume the volume formula of a cone is 1/3 pi r squared h. This is the volume of a cone. 1/3 pi r squared h. Volume of a cone. One of the many formulas you're going to need to have in the back of your mind. 1/3 pi r squared h. And again, I will give you a sheet full of formulas of various volumes and things like that. You'll be able to use those for this question here. So 1/3 pi r squared h. That's our formula for the volume of a cone. We got our equation. Now let's take our derivative. Let's take our derivative. We've got d dt of this thing. And so we're going to get dv dt equals. Here, now, this is a little tricky. We have radius, but we also have height. These are both variables here. So I need to do the derivative of each one, but I can't just go through, right, and just take the derivative of the radius and the derivative of h. What derivative rule do I need to do if these two variables are being multiplied together? What derivative rule do I need to use? That's right, everybody. I need to use the product rule. I need to do derivative of the first times the second plus derivative of the second times the first. I need to use my product rule here. So I'm going to do 1/3 pi and then do my product rule for the r and the h. I need to use the product rule. Product rule. The product rule said first times derivative of the second. So r squared derivative of h dh dt. First times derivative of the second. Plus, I do my second part of the product rule. Second times derivative of the first. H times the derivative of this r part is the power rule. Take the 2 in front, 2r. It's 2r, and then chain rule dr dt. Okay? So that is my little bit more complex of a derivative. Sometimes I have these two variables in a situation, and I have to do product rules because we're doing ddt of this. We're doing a derivative with respect to time, so I need to do the product rule for both these variables. So let's clean this up a little bit. dv dt equals 1/3 pi, right? The constant just stays out in front, right? This constant part just stays in front, right? Remember, constants just stay in front, and then you do the derivative part after here. So this is going to be r squared dh dt plus 2hr dr dt. Just clean it up a little bit. And now that we've got the equation, I just have to plug in all the knowns. Plug in all the pieces, all the pieces that I know into all the different variables and find the one I don't, right? I'm just going to plug in. I'm not even going to rearrange this. I'm just going to rearrange it after I get all the numbers plugged into it, because it's easier to move around numbers than it is to move around all these variables. So I'm going to plug in everything I know. What do I know? I know that h is 10, r is 5, dr dt is 1, and dv dt is 3. So I'm going to plug in everything I know. 3 is going to equal 1/3 pi times r, whoopsies, r was 5 squared. dh dt is the thing I don't know, so that's what we're going to find, plus 2 times h is 10, r is 5, and dr dt was 1. All right, everybody. Okay, so far? Got all the variables I was given. The r, dr dt, the r again here, the h, the volume change, all that stuff. The only thing I don't know now is this dh dt, and so I'm going to solve for that missing part. So let's do a little algebra here. 3 equals 1/3 pi times 25 dh dt plus, let's see, 20, let's see, it's 50, 50 times 2 is 100, that's the 100 here. And, kind of annoying, I'm going to have to distribute this 1/3, well, or, you know what, no, I'm going to multiply by 3 on both sides to cancel the 1/3 and divide by pi. Let's just do that. That's easier. So 9 over, oopsies. I might get rid of the 3, the 1/3 by multiplying by 3, dividing by pi. So I got 9 over pi equals 25 dh dt plus 100 minus 100 on both sides, minus 100. So it's going to be 9 over pi minus 100 equals 25 dh dt. Divide that by 25, divided by 25, divided by 25. And we've got dH dt equals, let's see, 9 over pi minus 100 over 25, which if we plug that into a calculator, we're going to get some interesting decimal answer. Let's see, 9 over pi minus 100 divided by 25 gets us about negative 3.885. Negative 3.885 what? I need my units to end this situation. dH/dt negative 3.885 what? What units am I going to put on here at the end? Every problem I need to put my units, or it will be marked incorrect on the AP test. What units do I need? Let's go back and look at what units we started with in the problem. What units do we have? feet per minute. Yeah, so it looks like it's going to be feet per minute. Everything's in feet and minutes. So negative 3.8 feet per minute. So that is the change of height of the water, of the height per minute. Now it's negative, which means I did something wrong. But it's probably because the numbers I chose randomly maybe didn't work out correctly. Who knows? Maybe the radius has to be bigger than the height. I did it backwards. Anyway, the process is the same. This is how you do this situation. You're going to get these answers. This answer doesn't make a lot of sense because it's negative. Why would the height be decreasing? I don't know. The numbers I chose were, I guess, a little arbitrary. Minus 10 raised 5. Maybe that should be like 0.1. Well, anyway, it's all fine. Any questions about this process here of finding various heights and situations? Let me do another one. I got 5 minutes. Let's see if I can fill it put this in 5 minutes. Another example. The speed of an airplane. Speed of an airplane. We are going to have a situation where an airplane, pardon my drawing, everyone, airplane, flying through the air, being tracked by a little satellite dish, right? Certain dimensions, tracking this airplane. Flying shark, yes, flying shark, for sure. We know the airplane is flying on a flight path that will take it directly over a radar tracking. The distance, S, to the airplane. This distance, X, horizontal distance to the radar tracking station. And we know this height here, the plane is 6 miles in the air. 6 miles in the air. The height of the plane is 6 miles in the air. The distance, this is an S, not a 5, an S. Really got to use some better variables. S. Oops, no. S. Goodness gracious. S. So we know a few things about this situation. We know that this is the sort of trajectory of the plane. The plane's going this way. It's going to fly directly over this radar station. We know that the radar pings the airplane, and we know that ds dt changes, decreases negative 400 miles per hour when S is 10 miles. So I want to know what is the speed of the plane. What is the plane speed? I want to know the speed of the plane get me the speed of the plane. So I know the radar distance. The radar is tracking this plane. It's pinging the plane every so often, and it tells when the distance to the plane S here is 10 miles. When this distance is 10 miles, this speed between the radar and the plane is decreasing at 400 miles an hour. So the plane is like moving this way, right? We know this distance is decreasing 400 miles an hour. What is the speed, the horizontal speed of the plane? So we're like triangulating the speed of this plane by using this, again, this right triangle and some knowledge we have about the hypotenuse of the triangle to get the horizontal distance and speed of the triangle. So what do we know? What do we need? What kind of formula can we use to determine the information? First of all, what even is the information we want? Well, if we want x here, I want the speed of the plane, right? X is the distance from the plane horizontally to the station. The speed is that change in distance over change in time. It's dx dt. And that's what I want to know. I want dx dt. I want this horizontal speed. This dx dt. I know ds dt. I know this. I know this is not moving. It's straight up and down 6 miles. It's not increasing or decreasing its height, although it could be, but let's hold that constant for now. I know that this is changing negative 400. I need to know what is the dx dt. So I got to come up with a formula that relates these three variables, the height here, this information s, this information x. What kind of formula can I use? Well, we got a right triangle, everybody. Let's think of all the right triangle tools that we have. Are we doing anything with angles? Do you think I'm going to do anything with sine, cosine, tangent? No. No, I don't know any angles. I don't know any angles. So I want to know what is dx dt. So we don't have no angles. No angles. So no SOHCAHTOA. So can't use really SOHCAHTOA. It's not going to help us here. I don't get any angles. Other thing we can have, well, we do have the Pythagorean theorem. Look at that. A squared plus b squared equals c squared. I got my Pythagorean theorem. That's my formula I'm going to use in this situation. So I've got x squared plus 6 squared equals s squared. So x squared plus 6 squared equals s squared. So that's the formula that we're going to use and we're going to do the derivative of that. Okay. And I got 1 minute left. Oh, I got negative 1 minute. Uh-oh. Can I finish this, everyone, or we got to go? Let me finish this quickly. Let's do a derivative, d dt. This is going to be 2x dx dt equals, that's going to go away, equals 2s ds dt. So I do my derivative. I plug in my known information. Plug in. I know that ds dt was negative 400. I know that s was, they said 10. This is 2. I don't know dx dt. That's what I'm looking for. Dx dt. I know that's a 2. Do I know x? Uh-oh. Do I know x? I don't know this yet. Something's missing. I need x. How do I get x? Well, I know that s is 10. If s is 10, I know this is 10. I can solve for the missing x. Solve for x. I get x squared plus 6 squared equals 10 squared. So go through that. X is going to turn out to be 8. So you may have to find some of the hidden information in these problems as you're doing it. You may need to use Pythagorean theorem one time to find out the missing side. Then once you got that, you can use it in the context of the problem. Solve this, you get, let's see, that's negative 4,000, negative 8,000 divided by 16 dx dt. It's going to be negative 8,000 divided by 16, which is going to be negative 500 miles per hour. Whew. All right. Your homework. To try some of these more complex problems. We meet again on Monday. So give these a shot over the weekend. Still page 157, 2.6. I'd like you to do numbers 16 through, let's see, 16 to 21. And then 25? No, 26. And 29. We'll go over these on Monday. Try it over the weekend. If you don't get it, that's fine. We'll go over it again. Practice these related rate questions. Yes, thank you, everyone. I hope you enjoy your weekend as well. Say goodbye in the chat. When you say goodbye, you are free to go. Thank you, everybody. Have a great one. See you next time.